Hi students, this is one of the interesting sums in circle. Let's see what's given in this particular part. There's a circle with segment AB as diameter. Line L is a tangent at point P. AX is perpendicular to line L and BY is perpendicular to line L. That means we are drawing two perpendiculars from the extreme ends of diameter AB. Now we are supposed to prove the feet of the perpendicular. The feet of the perpendicular means X and Y are equidistant from the center of the circle. That is to prove that OX is congruent to OY. Now there is a construction in this. Construction will be joining OX and OY, but I'll do it afterwards. Because the information given here is not enough to prove this particular sum. We have to find out something going off track. In standard 9, you have seen three parallel lines and intercept formula. We'll have to first derive some raw material from there. Let's see what can we do. First, can I write AX is perpendicular to line L, BY is perpendicular to line L. This is given. But OP will also be perpendicular to line L. What's the reason for OP to be perpendicular to line L? OP is a radius and line L is a tangent. So we know radius is always perpendicular to the tangent. Your tangent is perpendicular to the radius at the outer end. So this comes by tangent theorem, or you can call it radius is perpendicular to tangent. Now if you see, there are three lines which are perpendicular to the same line. So we have something in standard 9th. Perpendiculars to the same line are parallel to each other. So what I get is, therefore, AX parallel to BY parallel to OP. So can I put it up? Statement number 1, perpendiculars to same line are parallel to each other. That means line AX is parallel to OP parallel to BY, because these are the perpendiculars to the same line. Point number 3. If I consider AB as a transversal, if AB is a transversal, I should get AO is congruent to OB. Reason, radii of same circle. Now on the other hand, if I consider line L as transversal for the same parallel line, I will get XP is congruent to PY. So the system is that if we have three parallel lines, if first transversal makes congruent intercept, then any other transversal will also make congruent intercept. This property I am trying to apply here. So I got, if OA is congruent to OB because it is a radii of same circle, and if line L is a transversal to the same parallel lines, then I'll get XP is congruent to PY. So this is three parallel lines and intercept theorem. So with this, I got one information I told which was missing. So I got XP is congruent to PY. Let's see the construction. So I will have to join OX and OY. So now, statement number 4. Let's enter the two triangles in triangle OPX and triangle OPY. In triangle OPX and triangle OPY, please concentrate according to the information which are available, and one of the most important information what we have found out here. Can we write seg OP is congruent to seg OP? This is common side. Then we have angle OPX is congruent to angle OPY. This is because it's given OP perpendicular to line L. So I can write as radius perpendicular to tangent. Next, I'll use this one. What is that? PX. Seg PX is congruent to seg PY. Seg PX congruent to seg PY. That's what I proved in statement number 3. See now children, this two triangle, it's a segment, then an angle, then a segment. It's by SAS test we can prove both the triangles congruent. So I get therefore triangle OPX is congruent to triangle OPY by SAS test of congruence. We can tell the two triangles are congruent by SAS test of congruence. If the triangles are congruent, then I get hence seg OX congruent to seg OY. This is corresponding sides of congruent triangles. Is it the same thing what I want to prove that OX congruent to OY? That means the feet of the perpendiculars, the feet of the perpendicular point X and point Y are equidistant from center O. Thank you.